Hi folks, and welcome back to Math with Captain Ron here. Video I think 4 here in a series about inverse functions, exponentials, and logarithms. So this is where we left off, calculating values for these. I found my calculator. I went ahead and already filled these out. You can go ahead and grab these. And again, just take your calculator, hit log 7 equals, you'll get this. Hit natural log 13 equals, you'll get this, and so forth. Moving on. All right, evaluate and solve for x. So to solve these for x, let's write this in exponential form. This means 10 to the x equals 1,000. Now I'll go ahead and write this out. 1,000 is 10 to the third power. So 10 to the x equals 10 to the third, so x is equal to 3. Beautiful. Take a look at this one. If we write this in exponential form, this means x to the fourth equals 16. Now, 16 is 4 squared, so x to the fourth equals 4 squared, so x is equal to 4. Let's see this guy. This means 2 to the 0 equals x. Anything to the 0 is 1. Okay, this one, 4 squared equals x. Well, 4 squared is 16, so looking good. Moving on. All right, so a bunch of rules here. Product rule, power rule, quotient rule for logarithms. All right, so the product rule for a logarithm. Let me write it out and then go over it. If I have the log of two things, like log of a times b, that's equal to log a plus log b. All right, an example. Oh, let's see, if we had log of, say, 6x, we can write that as log of 6 plus log of x. I like to remember this. The log of a product is the sum of the logs. That's how I remember that. While we're at it, let's do the quotient rule. The log of a quotient, like a over b, that's equal to log a minus log b. I like to remember this by the log of a quotient is the difference of the logs. Oh, an example, well, how about log of 6 over x? That's equal to log 6 minus log x. Okay. Power rule for logarithms. If I have some sort of log, like with a number in front of it, like n times log x, this number can be written to the power of x, so this is equal to log x to the n. So I like to think about it like this. Log of something to a power, the power can come out in front. This is a very important property of logarithms that we'll be using quite a bit here to solve equations. Example of this, if we had log of x to the 5th power, that's equal to 5 times log of x. All right, so these are, again, very important properties for logarithms. This is the one we'll be using probably the most for solving exponential equations. All right, express as a single logarithm with a quotient of 1. So this animal right here, here's a power out in front, applying that power rule. This we can write as log base 6 of x to the minus 3rd. So single logarithm with a coefficient of 1, done. Okay, this guy. The log of a product is the sum of the logs. So this is equal to, right, the log of x squared y. This one. First of all, let's maybe apply the power rule here. This is going to be log base 5x to the 4th plus log base 5y squared. And now we can combine these as one logarithm. Log of the product is the sum of the logs. So this is log base 5 of x to the 4th y squared. That should be in parentheses. This one, right, applying power rules here, here, and here. We can write this one as log base 3 of x squared. The minus sign, we can either keep it with the 4 or leave it out front. Let's leave it out front and then put the 4 inside of here. So log base 3 of y to the 4th. Again, that minus sign could come in here, then you'd put a plus here and move on. All right, plus, and then this last term we can write as log base 3 of y to the 5th. All right, now, if we apply the product rule to this, then we're going to get log base 3 of x squared y to the 5th. And then we still have this minus log base 3y to the 4th. And now we can apply the quotient rule to this. So this is going to equal log base 3 of this, x squared y to the 5th, over this, y to the 4th. And this can be simplified. I'm out of room, so I'm going to keep going. But inside of here, y to the 5th over y to the 4th is just y. All right, this stuff here. So let's see. This 1/4 applies to both of these. So this term can be written log base 2 of x to the 1/4 plus this can be written log base 2 of y to the 1/4. And now we can use the property that the log of a product is the sum of the logs. So these can be basically absorbed into one logarithm. And we could write this xy to the 1/4, but I'm just going to leave that alone. Okay, this one, let's see, log base 3 of x. Now this is minus 4 here. Let's see, let's write this plus log base 3 of y to the minus 4. This time I'll go ahead and put the minus sign with the 4 and in the power. And let's do the same thing here. Plus, all right, keeping the minus sign with the 2. Log base 3 of y to the minus 2. All right, now that log of a product is the sum of the logs applies to not just 2 logarithms but 3. So we can write this as log base 3 of x y to the minus 4 y to the minus 2. And let's clean that up a little bit. That's going to be log base 3 of x over y to the 6th. Okay. This one bothers me. I just want to look this again. You got to be very careful with these parentheses. I just want to make sure I did this one right. Minus 4, that one up here, that's good. Oh, look at this. This product here, I forgot to apply that to this power. I got to go back. My apologies. We're going to work this one again. My bad. I'm glad I checked. Always be careful with parentheses. This term is good, negative 4 log base 3 of y, so there's my minus 4, that worked out okay. But this is plus 8 log base 3 of y, so that's going to be plus log base 3 y to the 8th. I'm glad I checked that. All right, now writing this as one logarithm. Log base 3 of x, y to the negative 4, y to the 8th, which is log base 3 of x, y to the 4th, by the time we take the y to the negative 4th times y to the 8th. All right, let's call that done and move on. All right, write the logarithm in expanded form. I would say they mean to do this. Let's write this log base 3 of 2 plus log base 3 of x. This lower left one. Okay, log of a quotient is the difference of the logs, so we can write this one log base 5 of x to the, I'm having trouble seeing that, I don't have my glasses on, give me a moment. I think that's a 3. All right, minus log base 5 of y to the 4th for the bottom. It just says expand, it doesn't say to bring these out front, so I'll just leave that alone. Okay, this guy. Here we have log base 6 of something to a power. The power is 1/3. So why don't we do this? 1/3 log base 6 of r squared z. And this can be expanded. log base 6 of r squared plus log base 6 of z. This is good enough. This 1/3 can be distributed, but we'll just leave it alone. This really should have parentheses around it. All right, natural log of all of this. This can be expanded out using the product of the log of a product is the sum of the logs. So this one is going to equal ln of x squared plus ln of y to the 6th plus ln of z. The directions just say to expand, so there's really no reason to do anything further, but you could write this one 2 ln x and this one 6 ln y, but it's not in the directions, so I'm not going to bother. All right, change the base formula. We're not going to really talk about that. What I'm going to do is show you how to change the base. All right, and remember this one we couldn't find an answer for, so what we're going to do now is we're going to solve that. Now, I actually write it up here. So we have 3 to the x equals 50. Now, what we're going to do is we're going to take the log of both sides. It does not matter what type of log you take. It doesn't matter if it's log base 10 or log base 100, or I'm sorry, or log base e. You want to use something that your calculator has. I'm going to go ahead and use base 10. So next line is going to read log base 10 of 3x equals log of base 10 of 50. And remember that beautiful power that the x can come down in front. So this is going to read x log 3 equals log 50. Now, log 3 and log 50, these are numbers that our calculator can calculate for us. So x is going to equal log 50 over log 3, and I'm just going to grab my calculator and get a numerical value. If I remember right, we guessed around 3.4 or something like that, but let's see what we get. So we're just going to take log 50, divide by log 3. I get 3.56 out of that for x. And again, this is a beautiful, beautiful thing, because now using this, a logarithmic function, we can solve equations like this that don't have nice, pretty answers. So let's go ahead and go through a few more examples here. I didn't type this, I don't know. Actually, we don't even need any of these directions here. The directions are are to figure out what these numbers are. Now, this is some number. Let's call it x. What we're going to do is write it in x. Equal sign went away. What we're going to do is write it in exponential form. So this means 7 to the x equals 100. Now what we're going to do is take the log of both sides. So log 7 to the x equals log 100. And use that beautiful property that this can now come out in front. So x times log 7 equals log 100. I'm kind of out of room here, but so x is going to equal log of 100 over log 7. Give me a moment here to get a value. I get about 2.366. Let's call it 2.37. I'm going to do one more, and then I'm going to leave these two as exercises to the reader. Let's work on this one right here. So this is equal to some number. Let's call it x. Okay, write it in exponential form. 5 to the x equals 8. Need a little bit of room here. Take the log of both sides. It doesn't matter if you use natural log or log base 10. I find that students seem to like log base 10 better, so even though natural log is less writing, I'll go ahead and write it log base 5 to the x equals log 8. Okay. Use the beautiful property that this x can now come out in front. It's log 8. Let me make that pretty. I'm going to be saving these notes for people for the future, I think. Okay, so remember that log 5 is just some number. So you got log 8, which is some number, divided by log 5. And at this point, we just calculate a value. Oops, didn't get my parentheses closed there. 1.29. I'm going to go ahead and leave this one and this one as an exercise to the reader here. Just write equals x, write it 10 to the x equals 500, take the log of both sides, right? And then the algebra step's the same. This one, write equals x, write it 7 to the x equals 1.2, then take the log of both sides. Again, I'm just going to leave that as practice for whoever's viewing this. All right, and let's see, on to graphing logarithmic functions. I think what I'll do here is, if you give me a moment, no, never mind. I'm just going to leave that as exercises to the reader. Again, write this equals x. Next step, 10 to the x equals 500. Take the log of both sides. This one right here, write this equals x. Next step, 7 to the x equals 1.2. Take the log of both sides. Should be good to go. So I hope this video helps with how to use logarithms to solve exponential equations. Have a great day.